All right, let's see. Welcome back to another episode of web development. In the last couple of weeks, were started to look at implementing the back end of our client server application, right? Implementing the server side of our client server application, right? Because we had reached some limitations of what we could possibly build just with the user interface. Just with the React user interface, we could, render forms for the user to fill out data and navigate between multiple screens and render multiple data structures and whatnot, and maintain some kind of state on the user interface. But there was no way for us to permanently store our state, right, or to survive a refresh. Right? So that's why, right, we started looking at uh, building an application that ran outside of the browser, right? That didn't have these limitations, right? That could run just like a regular application that would have access to the full operating system, integrate with the database, right? And full access to the network. Right? So we explored in the last couple of lectures on how to integrate these two pieces, right? The front end and the back end, now collaborating, right? Where the front end would offload some of the limitations that it had, right, so that the server could complement the user interface. Right? And we looked at the strategies on how to uh, establish the communication, establish some best practices and naming conventions, right, on how to design what the API was, right, that to use get, post, put, and delete for different purposes, right, for creating, reading, updating, and deleting data, and also how to write up the URL, the architecture of the URL, how to encode data and send over primary keys and query strings, right, and so we were learning how to integrate these two layers, right? And also we moved the data structures, right, that we were calling the database, right? We moved it over to the server, right? Uh, and um, and 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 we did mention that that was only a temporary solution, right? Because in reality, the database needs to be in a real database, right? And that's going to be the focus of the next couple of lectures, right? We're going to discuss how is it that we can integrate the server that we have currently, right, with an actual database. And we're going to be talking about using the MongoDB non-relational database, right, as our permanent storage solution, right? So we're going to use a library called Mongoose, right, that is going to integrate our server, right, with a Mongo database. We'll set it up so that it can connect locally to a local development instance of the database, right? We're going to do all our development there, and once we are confident that we have a working solution, right? We're going to migrate, right, our local instance, right, so that it can be run on a remote server, right? We're going to be hosting our database in a remote database, right, hosted by Mongo Atlas, right, and so that the remote server can communicate with this remote database, right? We're going to port all our data that we have currently, right? We're going to port it over to the database. So we're going to populate all the data that we currently have in JSON files. We're going to import it into our database, right? And we're going to have to write rewrite our DAOs so that instead of working with the local data structure on the server, right, the local files and the JSON files, instead of doing that, right, it's going to be talking to the database instead, right, where it should have been from the beginning, right? So that's the focus of the next couple of lectures. This this is the topic of uh, the final assignment, A6, right, assignment 6, right, that is going to give us a chance to practice, how to use databases and integrate. And so we're going to get started working on that. I'll get you going with the assignment. We'll work on some of the exercises and illustrate how to go on and finish it up on your own. Also, there's a couple of quizzes coming up, right? The Q8 is should be available sometime this week. right? Being in an online course, right? It'll be available throughout the week. So find a 20-minute window where you can take it. Also, the next quiz will be available in the next lecture. Okay. Let's see. All right. So these will be the last. The database integrating with the database will be the last formal course material, right, for the course. Right? We're expecting that you're feverishly working on the final project, right? Please don't leave that to the end, right? And you already have plenty of skills to be working on the front end, styling it, integrating with a server, right? And so you have plenty of skills to make plenty of progress in the implementation of whatever it is that you decided to work on, right? So please don't leave it to the end of the semester. It's going to get very, very busy. And so the last piece of all the techniques, all the skills that you need is we're going to be covering this week, right? How to integrate it with a database. Okay. And after that, right, we're going to be discussing other topics that are not core to the course, but certainly fairly interesting, right? How to integrate with third-party APIs, right? Databases that we don't own, that we don't control, right? How is it that we integrate, all these data sets that are available on the internet? How do we integrate it with our own projects, right? As well, how to integrate with AI tools such as ChatGPT and incorporate all those all that this awesome new field, right, into our own web applications. All right, so that's coming up right in the last couple of lectures, but there's no assignment associated to these last few topics. Right, just the assignment 6 is the last assignment. Right, so the last few weeks, right, there are no assignments. Right, so you should be focusing all your effort at completing the project. The project is due on the 14th week, right? That would be the when it's due, and and then after that there will be a demo week, right? So that last week, right, you're going to be demoing your project to the TAs or myself, right? And there'll be a checklist, right? That where it's basically the the design documents, right, the requirements document that we have already shared with you, but in the in the format of a checklist, right? So that the TAs and yourself can quickly go through the project that you've built, right, and go through making sure that everything's there, that all the requirements have been met, right? And I'll be sharing that with you shortly. Okay. All right. Let's get going. Right, so we're going to be using MongoDB as our permanent storage solution, right? So MongoDB is a non-relational database, right? That it's going to uh, form part of the backend, right? So we have been focusing all our effort. Most of the first half of the semester was, you know, uh, working on implementing our client, right? That was implemented using React.js, right? It's a JavaScript library that is designed for implementing single page applications, right? That render some form, some browsing and content in the user interface, right? In a browser, and then lately we have integrated our user interface with a server, right? And we've integrated them using a RESTful HTTP web API, right? And so the next these lectures are going to add this last piece, right? So that we can formally have a permanent storage solution, right? That can survive reboots, right? Have and so we have chosen to have to use Mongo, but again, certainly we could have chosen any other database, relational or non-relational. Right? So we're going to be using MongoDB. So the so MongoDB is a non-relational database, right? In that uh, for the most part, if you've taken a database course, most likely you have been introduced to relational databases, right? Where you break up your data in terms of multiple tables, right? And then you in these tables, each there it contains several records, right, in the form of rows in a table, right, where the columns in these rows are fields, right? They're that describe, right, what are the various properties of a particular data point, right? And then usually we the data in one row might be related to some other data in some other table, right? And so to be able to reconstruct the relationships, right? We add some fields in there that allow you to reference one record to another record. We have like a foreign key, a primary key, right, where the values match, right? And the meaning is that these two records are related to one another, right? So we're not going to do that. We're not using relational databases, even though they have been quite a bit, very, very popular for the last several decades, right? So instead, we're using a non-relational database where the paradigm of storing data, instead of breaking it up into multiple tables, in this case, collections, right? You instead have fields that can be rich, right? They can be hierarchical, right? They typically in a relational database, each one of the fields, right, it contains a primitive data type, right? An integer, a string, a boolean, right? Floating point, and things like that, or date. So these are all primitive data types. Whereas in a non-relational database, fields can be complex, right? Each record, instead of just having predetermined fields of primitive data types, what you store in there are objects that can be arbitrarily complex, right? Where objects can have multiple properties, right? And then each property can have other objects associated with them, right? And those objects can have nested arrays, objects that contain other arrays that contains other objects, so they can be, arbitrarily complex, right? Uh, Not to say that you can't have relationships. I mean, you can have fields or properties that have values that are meaningful to some other document in some other collection, right? But it's not the main focus, right? We are going to be using some of that. We'll use a combination of documents that are nested and have a lot of data structure in them, right? But also records or documents that have references to other documents, right? In these non-relational databases, we don't have a schema, right? Which is alarming, might be alarming for relational database folks, right? It says, well, how do you validate? And so the database itself doesn't have schemas, meaning when you store data in a collection or a record, right? Then there's not necessarily any validation from the database point of view, right? Instead, that job, that responsibility of validating, right, making sure that you're not inputting any bad data, that responsibility, we haven't just thrown it away. Instead, the responsibility has moved over to the application. It is the application now who's going to be responsible, right, for validating the data and making sure that you're not inputting bad records, bad fields into the database, right? So we do have validation, but it's just not the database who's doing the work. It is the application. Okay? And in our case, right, it's the architecture is going to look as follows, right? We have the database is only going to be responsible for storing the data, right? So it's going to host several collections, one per data structure, right? So for instance, we're going to have a collection for courses, another collection for users, and collections are equivalent to tables, right, in a relational database. right? So we're going to have a collection per, right, per user, the users collection, the courses collection, modules, and so on. And so the schema, or the description of the structure of the data of each one of these collections is not going to be, schemas are not going to live in the database. Instead, they're going to live in our Node.js application, right? And for this, we're going to use a library called Mongoose, right, to describe the structure of the data, right, to describe the schema. Right? In our case, in Mongoose, these are called Mongoose schemas, right? And they literally, look very much like the schema that you would use in a relational database, right? You list all the fields and what are the data types, right? What are the constraints? You say, this field is a string, right? You say whether it's required or not, whether you have some default values, things like that. Things that normally would live in a create table instruction, right? In a relational database, this has been moved over to a library, right? Mongoose library. And then on top of that, we have a model, or Mongoose model, that is going to have the responsibility of actually talking to the database. Right. This is equivalent in a relational database. Typically, you have an ORM, an object relational mapping library, right? That, like JPA, or one of these libraries that take an instance object, right? In a Java or C# or whatever, you have an object that then does the mapping, right? Into the into a record in a database, right? And then you have all sorts of functions in these ORMs to talk to the database, to insert, to update, to delete, right? To interact with the database. So that's what the model does. The model in Mongoose, right, plays the role, right, of a high level, well, not so high level, of a library of functions, right, that allow you to talk to the database, right, to insert, to update, to delete, right, to do all the CRUD operations for a given collection. Right? So you would have one Mongoose model per collection. So you have one schema per collection, right? And then you have a model that is associated to a schema that knows how to write and read and update and delete that kind of data set. Then on top of that, we're going to have a DAO, which we already have, right? But the DAO that we have written so far, right, is written to work with a local data structure, right? A whole bunch of JSON files, right, that contain arrays into this big object. Right? So as you remember, the DAO is a design pattern, right, that encapsulates all the CRUD operations that interacting with a data source, right? Providing some kind of high level API to the rest of the application, so that the rest of the application doesn't need to know whether you're using one database vendor versus another database vendor, right? It's all wrapped inside of this high level API or functions, right? That translate, right, the high level operations, right, into lower level operations that are idiosyncratic for that particular database vendor, right? So we're going to be overriding, right? We're going to be rewriting our DAOs, right, to, in this case, use the Mongoose library, right, to talk to the database as opposed to using the current arrays or objects that are manipulating or being read from the file system, right? So we're going to throw that away and replace it so that it talks to the database instead. The routes shouldn't change, okay? These are the integration points for the front end, for the user interface. Maybe we might need to change a little bit since the DAO was written to talk to local data structures, right, synchronously. Right? It was reading and writing these data structures, as part of the memory space, right, of the server. But now the DAO is going to be talking to the database, which is going to be remotely, it's running in some other memory space, right, in some other different process. So this communication is not going to be asynchronous, and because it's asynchronous, the routes might need to be refactor a little bit so that we add async await, right? So that because all this communication is now asynchronous. Yeah, so obviously the user interface, we don't have to change much in the user interface, other than perhaps, right, dealing with initialization and things like that. Right? Yeah, so NoSQL, as I mentioned earlier, right, um, it's a umbrella term for a family of databases that don't use SQL, right, as the main mechanism for interacting with a database system, right? They, instead of using the select, the insert, the update, the delete, English-like syntax, right? Instead, we use functions, right? That they do basically the same thing, right? They implement various CRUD operations, but the syntax is different. Instead of being, English-like text, right? That you write as ASCII. These are library calls, right? That basically do the same types of operations. You can find the Mongo database at mongodb.com. You'll need to download a database for this assignment, and the intent is that your database, your Mongo database, will be running locally on your machine, right? So that you can do all your development locally on your machine with your local React, Node.js application running, talking to your local Node.js HTTP server, talking to your local MongoDB database, right? And so you do all the development there until you're satisfied, right? And then we replicate, right, the environment, but in a remote server, right? The user interface, right? We deploy it to Netlify. The server, we deploy it to render.com or Heroku or whatever. And our database instance, right? We deploy, we we upload, right? We import all the data to a remote Mongo Atlas database, right? And obviously we need to tie everything together. Also, you can download a free version of the MongoDB if you go to download the community version of the Mongo database. So go there, download it, install it. Yeah, optionally you can when you install it, right, you'll get you'll get like a bin directory where you have executables in there, and so for as convenience, typically you might want to add the bin directory to your path, right, so that you can type in the executables right from the command line. For on Windows, typically that bin directory is under user's local MongoDB, right? There's a bin directory, so add that to your path using Mac OS. On Windows, there's a you can open up your environment variable editor, right, and add the path to your path variable, right? Now, if you're going to run it locally, right, from the command line, you'll need to create a directory. Well, you can call it whatever you want, but typically what I do is I create a data directory under my home directory. So if I go to home directory, I can create a data directory. Some folks prefer to create like a data / DB directory, and in there, right, this is going to be the place where your local instance is going to be storing all the files, right, that represent your database. Okay. Now, when you install the Mongo, right, it asks you on whether you want it to be executable from the command line like this, right, or if you prefer to install it as a service, right? And it's your choice, right? However you want to install and configure your database, that's fine, right? If it's a service, it means that typically it'll run all the time, right? When you shut off your computer, it stops, but then when you restart your computer, right, the database will automatically start for you. If you don't configure as a service, then you'll have to manually start the database server every time, right? when you boot up your computer, you have to manually start the computer the database, right, from the command line, right? So it's up to you however you want to configure it. Now on macOS, some of these commands you might need to use sudo, right? Since they are operating system level commands, right? That might need some your local authentication. Okay. Yeah, so for instance on Mac OS, right, you can run MongoD. MongoD is the database daemon, right, that starts up the server, the Mongo database server, right? It starts listening for incoming requests, right, to the database, right? So this is if you're doing it manually. If you do it manually, MongoDB, when it starts up, right, it's going to look for a database directory, right? And now you can provide the database, the data directory that you created, right? On your home directory, right? If that's where you created it, using the DB path flag, right? So and then you can provide here the where is it, right? Where is the path of the data directory that you created? So again, I have a local data directory on my home directory, right? So when I start my MongoDB, I start MongoD dash dash DB path and then the data directory like this, right? And so you just let me demo that real quick. So if we go to terminal. Okay, there we go. So I am at my local home directory, right? And I have a data directory somewhere that I've created a long time ago, right? And so I can, and my database, my MongoDB instance is installed locally on my user local Mongo, right? So that's my local database, and in there there's a bin directory, right? And in there there's a couple of executables, right? In particular, the one that I'm interested in is MongoD, right? So MongoD, like that. So that's the daemon that if I started, right, it's going to complain saying, I don't know where your data directory is. So I can provide it now. That is This is somewhat inconvenient where I have to type all the time /user /local /mongo blah 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 bin MongoD. If you want to be a little more convenient, right, you can add this directory, right, to your path, right, so that it'll be available all the time, and then you can just type MongoD, right? Oh, I ran it. Now notice that I ran it without telling it where my database path was, right? I noticed that it stopped, right? So it started. It doesn't know what directory to use to where to put its files and whatnot. So again, I have a data directory, so I'm in my local home directory, so I can say db path, right, and then data. So this time it's going to find it. Right? It's going to say, it's going to be happy and says, okay, now I have a location where I can store my database files, right? And now notice that it's listening at port 27,017, right? So that means that the database is ready to go, right? Ready to be used to store, remove, update, and delete, right? Data. Okay. Yeah, so it's up and running. Now, the typically the way you interact with the database are three main ways. One of them is you can interact with it from the command line, right? There are several command line interfaces, right, where you can send commands right from the command line. There's a visual way that you can interact with it, which is Compass, right? And there's also, you can interact with the database through a library, which is going to be Mongoose, right? So let's demonstrate how we can interact with it visually, right, with one of these Mongo clients. So Compass is a application also by MongoDB. Right, you can download it from there. You can search for it. You can install it. It's a DMG or executable zip file. right? And so it installs locally, and then you can run it, right? So you can run it like so. You can say compass, right? And it's a an application that starts up, maybe. Oh, there it is. There it is. So here's Mongo Compass, and you can create a new connection and say, create a new connection. Connections. Here's some connections that I have. You can say plus, and you can create a new connection. But here are a few connections that I've already created. But if you say plus, you can then provide the URL, right, that points to where the database is running. Locally, the database is running at 27,017, right? Localhost meaning my local machine. But if your database is running on Mongo Atlas or something, or this will be a much longer connection string. These are called connection strings, right? So it's a URL, right? Maybe even including so the IP address of where the computer, right, is on the web, right? And then the database server will be running on that computer, that IP address, but listening at a particular port, right? Locally on our machine is listening at 27,017. And so we can connect, right? It opens up a connection, and there it is. And what it does is that it asks the database, right, what databases do you have, right? It asks the server. So here's a few from prior courses, right, from other semesters. And so we're going to be creating a database for our, for our course, right? And so, for instance, let's create one for this course. No, not a connection. Sorry. Here we'll say I want to create a new database. I'll call it Canvas. Right. This is CS 5610 and SP15. And it asks you, well, I need the name of a collection, right? Again, collections are equivalent to tables. And so we'll start with creating a users collection, right? And at first it'll be empty. There's users. We can create, we can insert data. At first it's empty, there's nothing there. I can either import documents, or I can create new documents. So for instance, I can create a new document, and this is maybe Alice. This is create a user, say Alice, right? And so we'll create some ID, some bogus unique identifier. I will say that the username is Alice. Her password is 123. And she has the first name as Alice and last name Wonderland, right? And her role is she's an admin. Right, so we can insert that, right? Or we can import an entire JSON file, right? That can contain these records, right? So we could say add, say insert document. Well, not document. We can import JSON file. Let's see. Let's see. So 2025 springs, yes. Let's see. Our node are not JSON files, right? They're JavaScript files. The data we have as JSON files. We had it under here, under source, canvas, the database, right? And here are our users. And here we have user Iron Man and Dark Knight and whatnot, right? A whole bunch of users, and Ada 123 is there. And so let's select that and import, say import, and there it is. So now we have all sorts of users in there, right? We have Iron Man, Dark Knight, blah, blah, Ada. So you can either insert one by one, or you can import an entire JSON file and insert all these records in there. Okay. Anyway, so we have a database now for that particular data set, right? That particular collection, right? All right, so yeah, so we have a connection. We created you can create a database and the name of a collection. You can either insert a document or or import. Now you can also interact with this manually, right? In here we have at the bottom. Oop, where'd it go? Users. You can also start up a command line where you can interact with it manually. We're not going to get into those details, but here is briefly documented where you can at the command line type what database you want to use. So use and then the name of the database we just created. In our case would be Canvas, CS45 5610, Spring 25 and whatnot, right? And then once you're using that database, you can then start interacting with the collections under there, right? You can say db.courses.find, right? And then it retrieves all the courses in there, right? Then you can either find with no predicates, saying find all the courses, right? So it'll retrieve all the records in that collection, or you can specify filters, right? Where you have a JSON object that it'll be used to pattern match, right? All the records that match that criteria. So for instance, here we are matching by the primary key, right? And so it looks for a document that matches that primary key. uh, or right, you can pattern match against any field, right? Where you can pattern match by the field number, right? For instance, find the course whose number is RS4550, or right, and now it could be that it comes back with a single document or all the documents that match that criteria. Right? Here we have, for instance, if you filter by department, there might be many courses that are in that department, right? It's not all the courses, but it'll come back with a list of courses that match that criteria. Okay. Yeah, so you can interact with it visually using MongoDB Compass, or you can interact with it manually from the command line, which we're not covering, right? Or we can interact with it programmatically, right, using Mongoose, right? So let's take a look at Mongoose. So Mongoose, right, is a library that is going to allow us to programmatically talk to the database, right? Log into the database, establish a network connection, right, and issue the commands, all the CRUD commands, right, but programmatically using the library, right? So it's going to it's going to run on the server of the library, right, and it's going to connect to the remote database. Now the database could be anywhere on the network, right? It could be locally running on local host, but it could also be halfway across the world. As long as you know the IP address and the port number of where your database server is running, you can connect to it, right, and start interacting with it. Right. So let's install the Mongoose library, right, and create an instance, and then try to connect to our local database. Right? So to do that, right? Let's do that from our command line from our console here. So let's here's our Node.js HTTP server, and so let's see, where are we? Branch. So let's create a branch for this lecture. So we'll say BA5. Oh no, not A5. Sorry, A6. Give branch. Okay, A6. And so we'll do an npm install mongoose. Right, so that's the library that's going to allow us to programmatically connect to the Mongo database. Okay, and then to be able to connect to it in our index file, right? We're going to import the Mongoose library. So import the Mongoose library, and then we're going to connect to the database, right? So our AI already at work. Actually, this is a little bit too much. Now let's see, we have a cheat sheet over here. What we're going to do is that we're going to import the Mongoose library, and then we're going to establish a connection string. There you go, like that. And we know that we're actually, our database is, what is it, CS5610 Spring 25. That's the database. So the last part of the URL always needs to be, right, the name of the database that you want to connect to by default, right? So that's it. Now you can also have additional query strings at the end, right? But here we don't need to. When you're connecting remotely to Mongo Atlas, then yes, you will need a query string to further configure the connection. But locally, we just need the name of the database. In both cases, whether you're connecting locally or you're connecting remotely, always remember to include the name of the database as part of your connection string. Otherwise, you won't connect, right? Well, you'll connect, but you'll connect to the default database that won't be the one you want. It'll be some other database that Mongo Atlas will create for you. It won't be the database that you want, right? Then you'll go to Mongo Atlas and says, "Where's my data? I've been inserting and updating and whatnot, but I don't see it in the in my in Mongo Atlas, right?" And it turns out that it fell under some random default database, right? So yeah, so that establishes the connection. Let's see if this crashes. We'll do nodemon, right? Index. Okay, it didn't crash, so that means that it was able to establish a connection to the database. Great. Now, even better, we do want to configure the URL connection string to the database, right? Because locally, this is fine, right? It's connecting to localhost, right? And the port number, because our database is running locally, but we want to be able to configure this so that it also runs remotely, right? In the remote database when it connects to Mongo Atlas. But we don't know where this is running, right? So that what we're going to do is that we're going to leave it so that we can configure that, right? So let's we do have .env already installed. Yeah, we're using it already, or .env, for the session stuff, right? And so we're going to be also using it to configure the connection string. So what we'll do is that we'll add here, right, in front of the hard-coded connection string, right, we're going to add process env. So the connection string is going to be either process env Mongo connection string, that's going to be an environment variable, and if it's not defined, then we're going to default to our hard-coded URL that we know works, right? We know this URL works locally anyway. But if it's defined, then use the environment variable. And so in the environment variable, right, we're going to provide the database here, right? So for locally, this is CS5610, right, dash SP. Let me configure, let me confirm that. Yeah, canvas dash CS5610 SP25, canvas, blah, blah, blah. Okay. So it's gonna, because it's defined, it's gonna use this and try to connect to that. So the server should have restarted because I modified. And so anyway, let's restart it to make sure. Okay, there we go. All right, so it's connected, right? It's using this environment variable because it is defined, right? But then when it runs remotely, we'll have to remember to change this to point to wherever Mongo Atlas is running. In any case, always remember that the last part of these URL should be the name of the database. Okay, remember, if you don't provide that, the database is going to be chosen for you, right? So make sure that the
last part of this URL is the name of the database. Plus there might be a, an optional query string, whatever, a whole bunch of stuff there, okay? Local, we don't need that. We don't need the query string. Okay, so we're connected to the database. What do we want to do now? Now that we're connected to the database, we want to be able to start interacting with the database, right? So for that, right, we're going to need a model, right? The model, a Mongoose model, is the library that is going to allow us to talk to the database, but the model needs a schema. The schema is what defines the structure of the data that you're interacting with, right? It defines whether things are, certain properties are strings, Boolean, date, right? Or they are nested objects or arrays and whatnot, right? So let's create a schema for the user, right, that we just created. Right? So let's, oh, and I think we're gonna add another field here, underscore ID. So underscore ID, you'll have noticed that we have been using underscore ID quite a bit all throughout the semester, right? As a unique identifier for courses, for modules, for enrollments, for users, right? Now, if you omit the ID in the declaration of the schema, this is telling the Mongoose library that we're going to let the database choose the primary key for us, right? And it'll be some specific data type, right? A data type called object ID, right? Which is fine, right? Perhaps even preferable. But here we have JSON objects or files that we have imported that already have a primary key called underscore ID. So in that case, we are going to make ourselves responsible for that primary key. The value for that primary key has to be unique, right? And normally, right, if you omit the underscore ID, the database would be, right, responsible for creating these unique identifiers, right? But in our case, the data already existed, already had a structure. So we're saying here, hey, don't create it for me. I'm going to use some data sets that already have a value for underscore ID, and I will, it'll make it upon myself to make sure that this ID is indeed unique, right? So we have to make sure, which it's fine, but we already are doing that with a UID library, right? That it's already using and creating unique identifiers, right? So anyway, so this is in a user schema. So user schema. So in Canvas users, right, we're going to create a schema file, and we're going to paste the definition of the schema. And let's go over this real quick. All right, so as you see, right, we create schemas using the library Mongoose, which has and you can instantiate a new schema definition for data that lives in a collection in the database, right? So we're describing that data. We're telling Mongoose that, hey, that there's data in the database, right? These users. And we're just describing the data types, right? We're saying, hey, there's a username, there's a password, these are strings, right? And so notice that some of them are dates. I guess I'm only using strings and dates. That's all I'm using. Now the fields, right? Notice that the keys of these objects for the schema, these keys are the names of the fields that are describing the structure of each one of the record fields, right? And we're saying that these are strings, right? Some of them are dates, right, and so on. But now, if you're only specifying the data type, then you can just say the key and the data type, the key and the data type, the key and the data type, right? But, right, that's not the only constraint that we might want to establish, right? Because again, remember, a schema establishes the constraints on the data. That these are the field names I'm going to accept, and that these fields have a specific restriction on them, right? That they can be only strings or dates or Boolean or integers or whatnot, right? And so if you're only establishing that the constraint is that they are of a specific type, then you can just say, key type, key type. Now, if you're establishing other constraints, right? For instance, that it's required, right? That it's unique, right? That it has to adhere to a particular pattern, right? That it has a default value and things like that, right? Then, instead of just providing the data type, you can provide an object that configures that field, right? And in our case, now, whether you're using one or the other, you always have to provide what type it is, right? If you're using just the data type, then you just say the data type, right? But if you're providing a whole objects, then you have to specify the type by saying type, colon, and then the data type, right? And that's what we're doing here. So if you have an object to configure, then that means you can configure a whole bunch of other things, right? Now, if you're only, if in your object you only have type, then it's an overkill. You can just use this syntax instead, right? If I only had the type. If you have an object, it's because you intend to provide additional constraints such as required or unique. So for instance, username here, we're saying that it's required, right? Meaning if you try to insert a record without that field, you'll get an exception, right? You can also establish another constraint that this must be unique, right? That this username must be unique, right? That means that if you insert and there's another username that has some other record that has exactly the same username, then this will fail, okay? Now, this is expensive. This means that the database needs to compare this with all the records that are already there, right? So it needs to do a read, right? All the records have to scan the entire table, right? Or index it, right? To see if there's one that has, if it's an index, right? To check to see if that index already exists. And so, yeah, so here password, we're saying that it's required. It's not unique, meaning, two people can have the same password, but not two people have the same username, right? The role here is a string, but right, we don't want to accept any string for the role, right? We want to make sure that it falls within a given set of valid values, right? So we can use enum for that. We can say, oh, well, yeah, the role can be a string, but it can't be any string. It needs to be one of, student, faculty, admin, or user, right? And by default, right, if you don't give me the value, meaning this is an optional field, if you don't give me this field when you're inserting, right, I'll default to a user. Right? Then we have other things here like string, dates, and whatnot. And then finally, you have a meta configuration object at the end of the declaration of the schema, where you establish, where in the database is the data, right? And so in our case, right, it's in a collection called users, and that's what we're declaring here. The collection users is where the data is found, okay? Now, if you don't provide the name of the collection, right, then it'll assume a name, right? It'll guess what the name is. And typically the guess of the name, right, will be determined by the name of the model, which we haven't seen just yet, right? The name of the model plus a prefix, right? So it'll be maybe like user's model or something, right? But if you know exactly what the collection name is, then yes, configure it there. All right, so we have that. The next thing that we're going to need is a model, right? So let's create a model in user model. So here in user model, and it'll have this value. So let's go over it real quick. So we're still using the Mongoose library. We're importing the schema file, right, that declares the structure of the data, right? And then we're creating a new instance of a model using mongoose.model. And this takes two arguments. One is a unique name for the model. And so you can use any name, right? But you have to remember what that name is, right? You have to make sure that you're consistent with this name because it's going to be useful elsewhere, right? That name that you gave it. It also needs to be unique. Right? So if you do create two models that have the same name, right, Mongoose will throw an exception. And the next thing is the schema itself, right? It needs to know, that that it needs to know the structure of what it is that it's inserting or updating, right, or retrieving from the data. It needs to know the structure of that data. So we provide the schema, and then we just export it. Okay. Once we have the model contains all the functions that allow us to talk to the database, right? To retrieve data, to insert data, to update data, delete data, and whatnot. Okay. And so here we're doing is that we're going to use a DAO, which we already have. I believe we might already have a DAO for the users. Yeah, we already have a DAO. Now, our current DAO is built, based on a local file, right, that is collating a whole bunch of JavaScript files, right, that contain a whole bunch of data in there, right? So we're going to be replacing this implementation, right? And we're going to abandon the use of arrays in favor of the database, right? So we're going to, instead of using this database, right, we're going to instead use the model, right? And so, for instance, to implement the find all users, instead of returning the array, let's leave the create for now. But to find all users, right, we're going to use the model, right? The model.find, right? So find is a function of the Mongoose model library that retrieves or reads from the database, right? And it takes as argument, right, optionally, an object that can be used to pattern match what it is that you want to retrieve. It's like the where clause, right, in a select where clause in a statement in a relational database. Right here, if you don't provide any matching, any filtering, then that means that you're asking for all the records, right, in the database, right? Which is, I mean, yes, you could do that. It's just it's very seldom that you would do something like this where you retrieve all the records, because it could be, this could be thousands of records, right? But for our development purposes, it's fine. We only have just a few dozens. For finding a user by their primary key, right? We use this implementation. Right? Let's talk about it. So basically, oh, wait a minute. Right, so it's using the model. There's a find by ID function, right, that knows, right, to how to filter objects, how to find an object by its primary key, right? So here, find by ID. So it will compare it against the underscore ID field, right? Whatever ID we pass in, and then it returns the. So notice this is a default return, right? An implied return. So it returns whatever object it finds, right? And then find user by username. This is useful for identifying users that might already exist with that username, right? So the way it filters, now we know that username is unique, right? So that, if we are filtering by the username, right, we would typically only get one record back, or one object, one document. Now, if we could use just plain all, we could use just a plain all find, right, and provide a filter, but find always returns an array, right? And it could be cumbersome, right, or awkward or inconvenient, right, to deal with an array, especially if right, there's only one record. It'd be nice and very convenient if the single object could be returned instead of the array that contains a single object. So find one does that for us. It's a convenience function that says, yeah, it'll come back with an array of one, right? But I'm going to unwrap that and I'll give you the object itself, right? And then internally we have an object that is used for pattern matching to filter what it is that the record that we're looking for, right? For a username that matches the parameter username, right? That's what we want. Okay. Then we have credentials, right? We have that means that we're going to be filtering one, filter by credentials. Notice that we are replacing all these so that instead of using the array, right? Instead is using the model, right? Again, find by credentials, right? We're looking for a particular user, right? Whose username and password are known, right? And we're using perhaps to log in, right? To identify ourselves, where we're providing the username and password. So we're looking, is there a user whose username and password matches, right? And we know there's only one, right? And so we want the convenience of unwrapping that single matching document, right, out of the array. Now notice that here we're using the syntax, the shortened syntax of saying username colon username and password colon password, right? Like we did over here. Here we use the extended syntax, right, where we explicitly say property equal value, right? But we know that if the property and the value are the same, right, we can abbreviate that by just providing the name of the field, right? So that's what we've done here, right? We've abbreviated it. Okay. Update is we're no longer going to be updating an array. Instead, right, we're going to be using the model dot update one, right, meaning that we know that we're going to update a single document where, right, that we're going to pattern match we want to identify the document that we want to update. Say, ooh, this particular document we're going to update because I'm going to give you the primary key where the user ID matches the underscore ID. So this identifies the document, and then the second one modifies the document, right? And to do that, we have the set command, right? That merges, right, the documents that is already there with whatever fields or properties come in as the object, right? And so this will update only those fields, right, that are included in this user object. So if I'm updating the password only, then the user object might contain only the password, right, and its new value. And what set will do is it will update only that one field, right? If I'm updating my email and my phone number together, then the user would contain those two fields, right? And that what would be the two fields that would be updated. Okay. And finally, we have the delete. Delete, we are overriding that, and we're using the delete one. Delete one, where statement, right, or function, right, that takes as argument a filter that says, well, remove this particular document whose ID is this primary key value. Okay. All right. So we're not doing create user in it. We'll do that a little later. All right, so we have that, and then we also had routes to go with this, right? So the routes were written to use the DAO, which is fine, right? We'll need to update and change a few things, in particular because the our communication now with the DAO, right, is that we're talking to a database, a remote database, right? So it's running somewhere on the network, and so this is a remote asynchronous communication. So we'll need to revisit all these implementation. These all need to be async await, right? So yeah, so we'll need to add async await to all these, right, and make sure that all this communication is asynchronous. So let's do that right away. So let's add async to all these. All the functions need to be async. Profile, find, create course. Okay, that's it, right? And then, right, all the interactions with the DAO now need to be await. So let's do that. Let's add any interaction with the DAO needs to be awaited. Await. Here's await. Await sign in, wait. Request session, find courses, course DAO. Well, I don't know course DAO since we haven't touched the course. Course DAO. Okay, let's see if this crashed. Okay, it didn't crash. All right, excellent. So we did that. Let's see. Okay, we have all those. Perfect. Okay. The user routes, yeah, we already have declared that in our index, right? So that is done. User DAO, right, is user routes, right, is already declared, and it has an instance of the Express library. Okay, so yeah, so let's start playing around with these URLs, right? Let's check to see if they work. So find all users, right? Find all users. Let's see. So to try this out, right? We know that the user routes, we have a find all users. Let's use the DAO, right, that we have here, and it's implemented using the DAO find all users. Right? To implement that in the route, what we'll do is that we'll retrieve from using the DAO find all users, and then we'll just respond. Right? So we already have that listed here. Now, do we have the route declared? I believe we do. Get all users. There we go. Find all users. Right? It's this one. So we'll implement it using the DAOs. We'll say const users find all users, and then we'll respond with users. There we go. Okay. So let's try it out. This route, right? It's get users. So let's see. Should be able to. The database, the server is running at localhost 4000. So we should be able to say localhost 4000, right? And then what? Let's see, localhost, then users. To get all the users, it'll be /API/users. So /API/users. There we go. So these are, the users are in the database, right? So this went out to the server. The server intercepted it right here, right? Intercepted at this users. And then this made a request out to the DAO, find all users. Find all users made a model find, came back, right? Users, and then we responded with the users. Okay, yeah, that makes sense. Just to confirm, right, that this is indeed the data that is in the database and not some JSON file, although we see that this is the ID that we did create, right? But just to confirm, let's go to a database and let's make a quick change. So instead of Alice, let's change this to Alicia. Oop, Alicia, and I'll say update, and I'll refresh. There it is, right? So yeah, so any change we have made to the database, we do have access through an API. Perfect. All right, so the next thing would be, right, that we want to make this available, right, in the user interface, right? So what we're going to do is that, right, we're going to use the same Axios library that we've been using throughout the last several of lectures, right? We use Axios to be able to programmatically make queries from the React user interface application, right, to our server. So we already have that. What we might not have, right, is the client, right, implemented, to talk to the server to retrieve all the users, right. So let's work on that. First, let's start our run dev. Run dev. So we have a localhost 56, 5173. And so what we'll do is that to play around with this, right, we're going to try log in and whatnot, and then see if we can get some users, right? So let's see. So this login, right? We haven't touched the implementation of the sign in, sign up, right, profile, any of that in the client side. We haven't touched that. We've only updated, let's see, we've only updated the on the server side, we've updated the routes, right, to still use the same exact DAO. So our sign in, sign up, right, sign out profile, all that we didn't touch it at all. The only difference here is that our DAO now, right, is talking remotely to a server. So to find the credential, it's going to go out to a database, right, as opposed to a local array, right? So yeah, so let's try signing in. You can see the network, still should work the same way. So we'll say, Alice 123, sign in. Okay, so Alice came in, right, and the database came back as Alicia. There it is, Wonderland 123, and she doesn't have any courses, which is fine. Okay, so what we want to do is we're going to go to the account, and from the account we're going to notice that we are logged in. The profile shows everything. Let's add a screen where we can interact with the users, right? For instance, we'd like to be able to maybe retrieve all these users. We have the API. There it is, right? I want to be able to programmatically hit this API, right, and render it right here in a new screen. Let's try to do that. Okay. So let's in the account client, right? In the clients in the user interface, let's see, do we have a client? So we should have, right? In Canvas account, we have a client, and what do we have here? Let's see. And we have sign in, sign up, update profile, find my course. Okay, we don't have any interaction with the users. I mean, we do with individual users of signing in, signing out, profile and whatnot, but not the users in general, right? As a collection. Okay, so let's implement that. Let's implement find all users. That's going to do Axios get users with the API, right? Which is localhost 4000 API users. It's this same query right there, API users, right? So yeah, so that's what we're going to do right here from the client, and let's use this right from a brand new screen, right? So we already have table already is used in the user interface to render users, right? And I believe we have it implemented, right? So if we go to a course, let's say that I have, if I go to dashboard, or I go to a particular courses, RS 101, I go to people, this is hard-coded users, right, that live on the client, right? We want to instead go out to the server and retrieve all these users, right, to see if we can integrate these two things. Right now, notice that it's not going to the server for any of this, right? So if I go back to a dashboard and I go to a course, you'll notice that if I go to any course, right, and then I navigate to the people, notice that no communication is going out to the server. But instead, I do want to go out to the server to get all the data from the database, right? So let's do that. Let's implement. Let's refactor this so that it does display all the users. So what it is that we're going to, right now the current implementation is using, right, the current implementation in the account, in the where is it? Courses, modules, people. There it is. So right now, this table is just iterating over the users in a database, right? And it's filtering and based on the enrollments, blah blah blah. Let's remove all that. Let's move all that logic to the database, right? To the server where it belongs, right? So we're going to stop using the database. So no database, right? So we're breaking it. What else do we need, right? We're not going to use the parameters. We're not going to use the CI, none of that, no database, and we're not going to filter. I'm not going to filter. Instead, I'm going to pass you an array of users. So somebody else is going to figure out who the users are and we're going to pass them to you, right? So for now, the people table, the current implementation is that it's empty. There are no people because nobody passed me an array of users, right? So what we're going to do is that somebody's going to do the fetching. Somebody else is going to figure out, the people for this course is not going to be my responsibility. You're just going to pass me an array of users and I'll just render it, okay? So let's do that. So we did that already. And so let's create a new screen that is going to do the fetching. It's going to go out to the server, right? I'm going to call it user.tsx. So here, users.tsx, right, is going to, right, it's going to unload. It's going to go out to the server. See that? It's going to go out to the server. It's going to go out to client, find all the users. It's going to store them in a local state variable for caching, right? And then now I have an array of users that I can pass to the people table, and the people table will then render the users. Okay, and I'm going to navigate here with a new link, right? That is going to render this new users, right? So in the courses, right, we're going to have a new route that is going to allow me to navigate to my user screen that is going to pass this the users to the people table. Okay. Okay. And so I'm going to navigate with a brand new link that only if I am an admin I can navigate there. So I'm going to add this to the bottom of my links in my navigation in the account. So the account has a navigation that allows me to go to sign in, to sign up, to the profile. I'm going to add a new one that says that if the user is admin, right, then they can navigate to this new user screen, right? And I don't have active. Oh yeah, okay. I have active. Here, active says, if the path name, let me grab the path name. How am I grabbing the path name? Path name, I guess I'm not. So path name will be what? Would be use location, and then we're going to extract the path name like that. Okay, there we go. So use location, perfect. And if so, then it'll highlight it. Okay, all right, excellent. So yeah, so I need to be able to log in first. Let's try it out. Let's see, let's log in as an admin, an account, sign out. So I'm gonna log in as an admin. I guess Alice is an admin. Sign in. If I go to account, notice that I have the link to the users. I can click on it and it didn't work. Users, Canvas, users. So the profile, so I'm still logged in. I'm logged in. Account users, and the course users. So it's not matching. Why is it not matching? Canvas account users. No, not here, actually, not in the courses. Not in the courses, it would be in the accounts route. Accounts route right here. There we go. And I'll need to import that. There we go. Okay, so I can now navigate to profile and I go to users. I can see and notice that the users is coming from an API call, right? If I go to users, notice that, there we go. So it goes out to the server, fetches all the users, right? And I'm rendering all of them, right? And obviously only a system administrator would have access to this, right? If I'm not a system administrator, then I don't have access, right? So if I sign out and I log in as, let's see, Iron Man, let's change this to something simpler, like Iron, and 1, 2, 3. So let's update. So if I log in as Iron and 123, and I sign in. So Ironman, he is a faculty. So if I go to my account, notice that I don't have access to the users, right? Okay, so yeah, only if I'm an admin, then I have access to that. Okay. Yeah, excellent. So we have a list of users. Oh, so yeah, so this is a very common API, right, of retrieving all the documents. Let's go through several common interactions that we have from the user interface, right, to the back end, right, retrieving all the instances, right. If it's too many, probably you'll have some kind of pagination mechanism where I'm not really going to send you all the documents. Instead, I'll send you like a token or something so that you can continue asking me for more documents, right? But in general, yes, typically it will be some screen that allows you to display or navigate through the entire data set, right? Either paginated or like an infinite scroll, or so it's a very common operation. The other one, very common operation, is to retrieve documents by some predicate, right? That we already saw. Maybe we want to retrieve by their role, right? Or whether they're enrolled in a particular course or whatnot, right? So by some Boolean expression that if it matches this predicate, then I want those documents, right? So let's take a look at this. So for instance, an easy example is retrieving them by their role, right? So if you're an admin, I want to see all my faculty, I want to see all my students, right? So by role. So in the DAO, right? So let's create a finder method, right? In the DAO that filters here in the DAO, filters the users by their role, right? So maybe it's just find, model.find, and then filters by a pattern matches the role, right? And then let's create a URL for this, right? So find all users. So find all users by default just retrieves all the users, but right, when you are filtering by a predicate, typically you are asking for a subset of all the users, only the ones that match a particular criteria. So, and typically you encode these filters, right, as part of a query string. So question mark, right, and then you filter all the fields that you provide and the values that you want to filter by, right? Remember that if we're filtering by the primary key, we encode primary key as part of the path. But if we're filtering by something other than the primary key, we encode that in the query string, right? And so that's what we're doing here. So we're going to refactor our find all users, right, to see if there's something in the query string. If there is something in the query string, I want to filter by those fields, right? So yeah, so let's if we go to the routes where you have all the find all users, right, that we implemented earlier. Routes, that's current routes, create course. Find all users. I'm going to check to see, okay, well, is there a query string with the field role that we're filtering by the role? If there is, then I want to use this brand new DAO that I just wrote, right? That's going to filter all the users by their role and then just return those users and just return, abort continuing, right? If there is no query string, then I'm just going to do the default thing of just return to you all the users, right? So once I have that, right, in the user interface, what I can do is create a brand new client entry in my account, right here, that is going to allow me to encode the role at the end of the URL. See, that's a query role, and then I pass in the role that I want, right? So it's the same users API that I would use to retrieve all the users. It's exactly the same. It's just that I am encoding at the end, right, role equal role, right, that I can pass as a parameter. And so this will return to me a subset of all the users, not all of them, only the ones whose role matches here, right? So how do I enter the role that I want to filter by? So what I'll do is that in the my brand new user screen, I'll create an input field where I can, or maybe a drop down where I can select the role that I want to filter by, right? So that's what I'll do. I'll create here a state variable in my brand new users. In my brand new users here, right? I'll create a state variable, right? That I can select the role, and then when the role changes from a drop down, right? I'll set the value here, and then if there is a role, I'm going to go fetch it and then set the users with the subset users. Otherwise, I'm just going to fetch all the users, right? So let's have a drop down. So he'll be my drop down that I'm going to be able to select the role of student, TA, faculty, or admin. And when I select something, then it will fire the query, right? So we'll put users here. This is my drop down, and let's see what this looks like. So let's see. Let's sign in as an admin. So this will be Alice 123, sign in. So I go to my account, users. There we go. Right. So notice that I have all roles. Maybe make it look a little prettier. We'll put a break, a couple breaks here. Right, so notice that right now it's retrieving all the users, so all of them, but I want to filter, say, by students. So students, okay, notice it's less. Notice the URL that went out. You see that? Right, it's a URL that goes out and encodes role equals student, right? And the response is that it comes back with less, less number of users. So instead of students, it could be assistants. There's 2. Faculty, there's 2. Administrators, there's Alice and Ada, right? Those are the 2 system administrators, right? Or all the roles, which returns all of them. Okay, perfect. Other ways that we might want to filter are maybe by a regular expression, right? Maybe as I type the name of the user or an email or first name or last name, I want to pattern match against several fields at once, right? And if it matches a regular expression, right? So let's do that. So let's use in the DAO, right? We can filter, find users by some partial name, and so we're going to pass in some partial names and a few characters. Here we're creating a regular expression, right, out of the partial name, and then we say we do a model find and use a Boolean expression to see pattern matching where one of these matches the regular expression, either if the first name, the last name, just those 2. But it could be anything. It could be also the username. It could be an email, right? So if you want to pattern match a whole bunch of these things, right? But here, any one of them matches, or right, this is true or that is true, where the first name matches the regular expression, then give me back those records that match this Boolean expression, right? And then using the same exact find all users where we can check if there's a query for the role, right? If there is no role, well, maybe there's a partial name, right? So we can check for that too. And we can say, well, if there is a name in the query string, right, in the routes, we can say, okay, well, if there's no role, then we can maybe check to see if there's a partial name, right, in the query, and we'll extract the name from the query. So if there is, then use this brand new find users by partial name, right, and then return the users that match, right? So then in the user interface, right, we can have an API call in the client, right? In the client, we can send in as another query parameter, right, name, and then the partial name that we want to filter by, right? And then it comes back with a subset of those users that match that partial name, right? So, and the way we can drive this in the user interface in our brand new user screens, that maybe we could have like an input field that you can type, and as you type, it'll send a request, for every character that you type, right? And then it'll shorten the users that match, right? So here we have the a state variable where we can, we can type the partial name, right, in our users. So here's our state variable that we're the partial name, and then for every character that we type, we're going to make a query, right, out to the server, says, hey, find users by partial name. It comes back and we'll update the local list of users, right, and the list will shorten as we type. Okay, so to drive this, we'll need an input field, right, where as we type, it'll call these filter users by name, right? So we'll put the input field maybe right next to the select statement, like that, and let's see what this looks like. For this, there's our search, and we can type maybe Stark. There we go. So it's Stark, or Wayne W. So it's Wonderland and Wayne, or Anner. So banner, so is land, right, or banner, or Raman off. Right, so as we type, notice that the queries are going out, right? So it's a very chatty implementation, right? So as we type, right, notice that it goes. So name A, so it finds anybody who has a either first name or last name that has an A. So it's a subset, right? And that's another query. It comes back with only 3, right? And you see the query going out, right, with a an, and so on. Okay. All right. Let's take a break. And when we come back, we'll implement a few other implementations, interactions with the database. So very short break. We'll be right back. Don't go anywhere. All right, we're back. All right, so we've implemented several interactions between the user interface and the server database, and so some of the more common operations, right? Being able to retrieve all the documents from a collection, or documents, a subset of documents that meet a particular criteria, right? A predicate. Another very common operation is that we want to retrieve a document by its primary key, right? And so the Mongoose library has a dedicated function, right, that knows how to filter, right, pattern match documents by their primary key, right? And it's called find by ID. Find users by their user ID, which I believe we might already have implemented in our DAO. Find user by ID, and then our route, right? We need, there it is. So we need to implement the find user by ID route, right? And by what we do is use the DAO that finds the user by ID and then return that user. Right? So let's implement that in the route find user by ID, which is going to parse the ID from the request parameters, right? So there should be a URL, right? That there it is. So get the users by their ID, find user by ID. So notice the pattern here, right? That what we encode in the URL is only nouns, plural nouns, and primary keys. That's all we put in the path. Right? Anything else that we want to filter by, like this one's so we can filter by their primary key. But if we want to filter by something else, we would encode it as part of the query string, which is actually at the end of here, right? The find all users. It's the only get, right, that matches all users, but then with an optional query string at the end, right? And that's not part, right? The query right? The pattern for the query is not part of the declaration of the route, right? That instead is handled inside of the function where you can retrieve the query and then filter as you want, right? But now we're implementing the find user by ID, which is encoding the ID as part of the path, right? Again, following RESTful Web API conventions, right? We extract the user ID and then we use it to filter that particular user and then retrieve it, right? Then in the user interface, right, we can create a client function, right, that is going to query this, right? So it would be the client over here. Do we have a user find by user ID? No, we don't. Okay, so there it is. So it's going to notice that all the other filters, right, the non-primary key filters are encoded in the query string, but the primary key filter is encoded as part of the path, right? Again, that's just convention. And so let's use this, right, to display that particular user. Right? I mean, that is the intent of that web API, right? If you give me the ID of a user, I'll retrieve that particular user from the database. If you don't give me the ID, then I'll retrieve all of them. Okay? So let's use it to go fetch this particular user. So for that, let's implement a new screen. Right? Call it the details screen. So under people, we have either a table that renders all the users, and we also have a details, which renders a single user. So table renders, a list of users, whereas details of the people, right, just renders one, right? And so let's implement it here, and let's discuss how about the implementation. So the way this would work is that it uses the client. The client. Do we have a client? I don't think that's where the client is. Let's see. I think it's up here. It needs to go up one, then account, and then client. Account. Isn't that where the client is? Client TSS. Oh, slash. There we go. Okay, so that's the client. And that client does indeed have a find user by ID. Perfect. All right, so maybe I do want to fix that in the slide. Let me put that in there. There we go. And so in there, what it does is that it's going to parse the course and the ID out of the use params, and then unload is going to fetch the user with the user ID, right? It's going to do a client find user by ID with the primary key. It's going to retrieve the user and set the user, and then it's going to render that user. It's going to render the first name and last name of the user plus login information and section and blah, blah, blah about that user. Now, the place where we're going to render, we want to render like this. And to render like this, we are going to include it in the table. Let's include it in the table. We'll render it like right here, details. Details. People details. Oh, people details. So people, no, people table, no, people detail. There we go. So go render people details, but by default, the people detail, right? If there is no ID, if it doesn't encode the ID, it's not going to render anything, right? So it'll be null. Only if there's an ID. So to implement this, what we'll do is when we navigate on that user, on the user table, right? It's right here. We have users. But if we have users that also include the user ID, let's see, details, it's expecting user UID. I also don't want to render the users, right? But right, if I don't have the users, it'll include the table, right? Plus it'll include the, do I want it in there or here? Let's see. I think it's good like that. Let's see. And then we need here a link that will allow us to navigate to that, to, slash users and then the ID of the user. So let's do that too. In the table, we'll make the user, right? We'll make a link here. Do I have that in my cheat sheet? I might not have it. I don't, right? We need to create a link. So we'll say we'll create a link. This will include, right? We'll encode the ID as part of the URL. So I can click the username. You can click on the username and we'll navigate to user ID. And that will encode the ID and will cause the details to display, right? So let's try it out. There, so these are links. When I click on it, there we go. I notice what happened, right? Right. I've encoded the ID in the user. So typically, if I go users and I click on this, Tony Stark, right? Notice that it encodes the ID and then it fetches the ID, retrieves Tony Stark. See that? Right. If I then click on Bruce Banner, right? Notice that it fetches the user for 234, because the ID is changing, and notice that the ID has been declared in the details, has been declared as a dependency over here, right? Meaning that if the UID changes, as we parse it from the user parameters, if it changes, it will cause a new fetch to run the use effect again to fetch a new user and update it over here. Okay. Now, the link to close it, this link to close it, what we'll probably want to do is just go to Canvas account users and remove the 234. So this will go Canvas account and then users, like that. So that if I click on this, it'll basically remove the ID and then just close it, right? Because if there is no ID, the user detail just returns null and it doesn't render anything. Okay. Right, perfect, excellent. So now if I can go Bruce Banner, click Aragorn, right, or Legolas, right, and it closes. Okay, perfect. All right, so how about removing a document, right? Yeah, so we already have in the DAO removing a document, right? So here we did implement the delete one, I believe. Yeah, delete user using delete one with the user ID encoded. So we have that already. Now let's see if we implement it here in the route. We do have a app delete, right, that includes the ID in the route, and delete user is not implemented. So let's implement that, right? So what we'll do is that so anyway, so we have it here, I believe. Yeah, there it is. So we're gonna do a wait on the DAO delete user, pass in the user ID as an argument, right? And then just return the status. Now the status here, but that comes back from the delete user, from this delete one. Delete one, notice that all these find, right, this model find, all these find one, they all return data, right? Users, either one user or multiple users, right? An array of users, right? Or a single user. But delete and update, these two, update and delete, they don't return documents. They don't return users or array of users. They return status information, whether it was successful or not, how many documents were affected, right? And so on, right? So it returns some meta information about the operation and whether it was successful or not. And that's what we're doing here. We are basically, retrieving the status that it comes back from having executed that statement, right? And then we're just responding with that status, right? Yeah, so then now in the user interface, after we delete, right, we want to be able to invoke the delete from the client, right? So let's do that. In the client, in the user interface, right, we're going to invoke the delete user. We're going to encode the user ID of the user that we want to remove, and we're going to use axios.delete. And we're going to invoke that by clicking in a brand new delete object, right? In a delete object. So let's see, fetch users. Yeah, so we're going to pass the fetch users to the people details so that when we do remove, right, we're going to do a query to go fetch the users again, right, so that we can display the latest version of the users, which will include this missing user that we just removed. Okay, so in the details, right, we are going to people details. We are going to need use navigate so that we can navigate back to the users without the ID. So this would be canvas account users actually. So let's I'm gonna pass in the user and the navigate. So here's delete user, right? And we're gonna call it when we click on a new button, and then once we remove, we're gonna call the client to delete the user. Comes back, right? And then we fetch the brand new users so that they get refreshed, and then we navigate back to users so that we remove the dialog box on the right hand side. Okay, so let's also add a brand new button. So at the bottom, right, at the bottom we can click on delete, right? So down here, and actually we're navigating to count users. Will we cancel, and then we click on delete over here. All right, so let's try it out. Let's see. So when I fetch Tony, there's our delete button, right? Here's Bruce Banner, right? And then when I click on cancel, it's just going to navigate to users, right? It's not going to do anything. Oh, we do need to pass in the fetch here, fetch users in where? In the table, do we have fetch user here? We don't have fetch users. So maybe this is not the best place to have it. The people table. People table, this is not what we fetch. We fetch in users, no? Fetch users. So it's better to maybe have the people details not here, but in the users right here. I think is a better place to put it. Now it doesn't matter because it's an overlay, right? It overlays whatever it is that you already have in the background. So here we can pass in fetch users, a reference to the local fetch users function. Okay, so if do cancel, it removes. So it works the same way. Bruce Banner, let's remove Bruce Banner. So if I click on delete, so there it is. So the delete went out, right? Notice the headers that went out, the delete went out. See a delete, encoding the ID of Bruce Banner at the end. And the response comes back saying, this is what came back from the database, right? That yes, one count, one document was removed, and I acknowledge that it was successful to true. And notice that indeed Bruce Banner is no longer there. If I refresh, notice that yeah, Bruce Banner is no longer there. I can move Bruce Wayne. You can delete. It's gone, right? Romanov, delete, and it's gone. If I refresh, it's permanent, right? They're removed from the database. It's gone forever. Okay. All right. And how about being able to update documents, right? For instance, we already have in the DAO implemented the DAO for updating the document, right? Using the update one, right? The update one and using set to update. But I don't believe we implemented it in the route. Let's see, we have a put here. Here's our put for updating the user. Yes, it's okay, it is implemented, right? Let's see. update user, blah, 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 status, yada, yada. Okay, so it works. So then in the user, on the client side, right, we need to send this update, which we might already have that from a prior, let's see, update. Do we have update here? Okay, we do have update, da, da, da. Okay, so that works. So that's already there. And now what we want to do is be able to, change the name of the user, right? And then and try to now the way we display the name of the user, notice that is one, one string, right? And what we're gonna do is that we're gonna replace that with an input field, if we're editing it, right? And as we're editing it, it's gonna be one string. And what we have to do is the new name is going to have also first name and last name. We're going to have to split it into two strings so that we can update each one individually. The first and the last name as two separate fields, right? So let's do that. So let's create an input field, right? Where we can type the whole name and then we'll split it. So we'll copy that, and we'll do that in the details. So details. And there it is. So that save user, and it's also going to navigate again to account and then users. It's going to split it. It's going to update the user, right? Where we're going to set the first and last name, right? And then editing false, right? And editing is going to either show or hide the input field, right? And here it is. So the first name and last name, we're going to wrap it around, right, with this new pencil that we can click on it so that we can edit it, and we'll replace it by an input field where we can type the new name, right? So our first name and last name, there they are. I'm going to replace this with this, which says with these new icons, pencil and check mark, right, to to notify them whether our intent is to edit the field, and when we're done editing the field. So if I press on the pencil, right, it's going to turn on the edit to true, and if I save, it's going to set it to false, right? So it's going to toggle the show or hiding of either the first and last name, just the values, or if I'm editing, right, the input field for be able to edit the username and password, right? By default, the initial value will be the concatenation of the first and last name. That will be its default value. But then as I type, right, and I press enter, then it'll take the whole string, we'll split it, right? We'll split it, right? And then do the update, okay? All right, now one thing on the server in the updates, notice that we are in the session changing the user. Now this makes sense if I'm changing my own name, but if I'm not, then I don't want to change the session, right? So the current user, if I'm logged in and I'm editing someone else, I don't want to do the change in the session, right? So only if it's my user ID. So if it's, so here we'd say, if the current user dot underscore ID is equal to the user ID, meaning I'm changing my own, then yes, I want to update the session. Otherwise, I don't, right? Because I am modifying someone else's first and last name, right? Not my own, because I want to stay logged in, and I don't want to change. I don't want to change my own, right? Especially if I'm changing some other fields that would change maybe the role. If I used to be an admin and now I'm automatically changing something that is not an admin, might be dangerous, right? And log me out, and I can't access it. I can't do any of my changes. Okay. So yeah. So let's see. And then yeah, let's create user. Okay, so we'll do that. Wait a minute. Create. No, that's create. Update. All right. So let's try it out. And so first, I'll probably need to log in. I'm still logged in as Alice. I did change the server, didn't I? I did change the server, so I should have restarted. How come I still logged in? Okay, no, I'm not logged in. I'm still, okay, so let me go to account. Yeah, let me sign in. So Alice, 1, 2, 3, sign in. Okay, account, users, perfect. Okay, so let me see if I can change something. Let me go to Tony. I can say, again, edit. Notice that it changes to an input field, so I should be able to change Tony. I'll say Antonio. Let's see the update that goes out. So it says, okay, I'll do an enter. There it is, Antonio Stark, right? Notice that the put went out, right? There's our put, right, to ID 123. We're changing the first name and last name. Oh, and then response comes back with Antonio. Yeah, it was up, it was changed, and then I'm fetching the users to re-update. So that works, perfect, excellent. And finally, we might want to be able to create brand new users, right? We already have a create user. Now, this implementation is was for when we weren't using unique identifiers. We were letting the server, the database, come up with their own IDs. So instead, we're going to use UUID to create the user, right? So this implementation on the server, right, is going to be the same as we implement when we instantiate, say, a course, right? We use a UUID, that one right there. We're going to import that, same thing in the DAO for the users. So let's, oh, we already have it. Oh, there it is. Okay, so we do have new users. Okay, so instead of adding it to the array, right, let's not do that. Instead, we're going to use DAO dot, oops, dot create user, new user, which it's not implemented yet. Okay, no, it's using the model. So we are in the DAO. So this is the model dot create, like that. So that's going to create this. That's going to do an insert, right, with a ID with a unique identifier. It's going to create one, and that is going to be sent when we do a post, right? Do app posts for user, create user. Okay, and so we're going to do new user, create user, request body, and we're going to respond with new user. Perfect. Okay, perfect. And so on the so that's on the server. On the client, we are, so yeah. So let me change this to be create user. Yeah, let me remove that. So it's this, right? There we go, like that. New user, and this is the new user. So let me this console 41. There we go. And let me fix that. Perfect. Okay. All right, we got a new user. Perfect. And a response with the new user. Create user, DAO. Perfect. Okay. So on the client side, right, we want to do the post. Do the post on the client. Here's the client. So we have a sign up. Do we have a create user? Create course. Create. Okay, we don't have create. Okay, create user. There it is. I'm going to post to that API we just created. And we're going to invoke that from the table. We're going to add a new button, right, that is going to invoke this to create a new user. And it's going to come up with some bogus first name, first last name, right, some bogus username. We can edit that later, right, by clicking on it and then going into the editor, right? So let's, so on the, in the table, right, let's have a handler to create a new user. We'll have to import the client, or maybe actually not in the people table. Maybe I think a better implement use is in the users, right? Here in the users already have the client here, right? I have the client, so let's add it here. I think this is a better place. Create user, and let's add a button. Let's add a button. maybe at the top, right by the user heading, right here, right? So let's add maybe a button right there. We'll import this plus. So if we want to add a new person, let's see. There's so new people right here. And so I'm going to call that function, right? The create user, which is this one, which is going to send, who's going to post this new user to the server, all right? So yeah, so let's click on that. There it is. So notice that it went out. The user went out, right? It's a post that went out, right? It's a post which inserts this new user in the database. We can check that. In here, we can refresh and check to see that this new user indeed has been inserted. And then we can edit it. We can say, click on it and then edit it, right? And this is, Bob Marley or something, right? Marley. Enter, and then it updates. Notice if I refresh, notice that it's permanent, right? And we can change, we can add a couple more, right? So edit this one. This is Charlie Brown, right? Right, and Ed Norton, right? And so these users have been inserted and they have been updated. If I refresh, you'll notice that indeed, Charlie Brown and Ed Norton have been updated in the database. Okay. All right. Yeah. So let's leave it here. Yeah, let's have a short break and we'll do office hours. Okay. All right. I'll be right back.